Today I had mechanics class and I'm just gonna give an overview of what I did. The paper was May-June 2016 mechanics for AS level, which is paper 42. I attempted question number 1 and 2I. With that being said, let's get into the video. Alright, the question asks us to find out the resultant and the direction of the force. So, what's the magnitude of the resultant force and the direction? We are given three forces acting at a point, and the forces are 8 newtons, 7 newtons, and 6 newtons. As you can see, there is an angle which is alpha, and we are given 90 degree over here and this side. So they gave us the value of sine alpha, which is equal to 3 divided by 5. That helps us let us know that this value is sine alpha 3 divided by 5. Or if it's cos, we use Pythagoras and do it that way. So now let's see what we did in the notebook. So this is what I did, and whenever I get a question like this where there are three forces, I usually think of taking f sine theta, f cos theta, and just dividing them to get the tangent, and thus finding the angle and all that sort of stuff. But I didn't have any idea what to do here, so this is what I initially did. So I took F net, which is the resultant force. They're asking us to find the resultant force, and we don't know the resultant force. Thereby I just put some random stuff such like this: F sine theta plus F cos theta. It is unintelligible, so this is wrong. It should be if I was really if I really thought about it, it should be F sine theta divided by F cos theta, but even that is wrong, and I'll get to that now. So looking at the diagram, I took the idea that upward force equal downward force, and rightward force is equal to leftward force, and I applied that idea right here by taking 8 sine b. B is the angle which is at here, it's near the 8, plus sine should be 6 sine alpha equal to 7. So this is the 8 sine b, and below is the 8 sine alpha. Thus, if you sum them both, it will be equal to 7, or it could not be equal to 7, but I wrote it is equal to 7. So leftward force is equal to rightward force. That's the idea which I put, and that's what I'm used to with these type of questions, and I'm faced with mainly equilibrium questions, but this is not an equilibrium question. It could go either way. So since I didn't know what was B, which is the angle right here, and I didn't know what the angle is, I could deduce what A was, alpha was. I would just substitute what was given to me in the question, and thereby I would get it. But at this moment I didn't know, so I left it. So now I went to the vertical forces after I was done with the horizontal. I didn't know what to do with the horizontal, so now having the vertical forces, 8 cos b minus 6 cos alpha. As you can see here, 8 cos b is this one right here, and 6 cos alpha is this one right here, and they're acting at opposite directions, thereby getting us value which may be equal or which may be a different value whatsoever. So overall I put this equal to f cos x, or I could actually put fy, just denoting the vertical axis, the vertical forces. Having been stuck in this problem, I asked a friend for help. He long ago finished this question when I was just up till here. I asked him to give me the clue for what B was, and he said to get B you should note this down right here. So this is the value which wasn't given in the question. Sine inverse of this takes sine to the other side, and I got 36.9 as the angle for alpha. So alpha right here is 36.9. So B stands on a 180 line from alpha, and this right here is a 90 degree angle here. Given that we know all of this, alpha being 36.9 and this being 90 and this standing on a 180-degree line, I deduce to this 180 minus bracket 36.9 plus 90 must be a bracket there, and eventually I got 53.1. So the angle for B is 53.1. You can tell I'm very rusty just by asking a simple question such as this. Now that out of the way, I now put the 8 cos B and I replace the B with 53.1, and knowing this I got 1.59, which was again wrong initially because I mixed cos with sine. I put sine instead of cos in the calculator, thus getting a wrong answer. And even after I put cos, I still got the wrong answer. And I was left basically in a fog and I didn't know where to go from here. I thought my calculator was getting the wrong answer. I still kept on repeating, trying to see where I went wrong. I came along this line trying to see if I could get the right answer here. As you can see, I placed the values down and I eventually got the right answer, but this was not my original answer. Once I placed this down initially, I mixed the two. I mixed it by saying 8 sine. Instead of 53.1, I put 36.9. And right here 6 sine 50, I put 53.9, which is overall a mixed up idea. Alpha is 36.9, B is beta is 53.1. so after all the pebbles on the road, we could still find the answer, and we got 2.99. that's the answer, and we should round this to 3. That's because our question has the value of 3 of one significant figure. If the question was in any other significant figure, then we would put in that significant figure as it states in the question. As the value of 867 is one significant figure, thereby our answer should be in one significant figure. So after finding the answer, I went down and tried to get the value here, and eventually I got the answer, but I still had a problem. If you plug this in the calculator, you will still get the wrong answer and you won't get 0. Before I go on that, you might be wondering how I got 4 by 5. Shouldn't it be 3 by 5 as stated in here? So since this is cos, which is acting down the line, we're not trying to find sine. Given that in mind, how do we come to cos? Since we know sine alpha is equal to 3 by 5, how do we get cos? We use Pythagoras. Since hypotenuse is 5 and opposite is 3, I plug this in my Pythagoras formula to get the adjacent value, which is 4. This is to fit the value right here, since S is equal to O divided by H, which is opposite divided by hypotenuse. Cos is equal to adjacent divided by hypotenuse, thereby adjacent is 4. Adjacent divided by hypotenuse is going to be looking like 4 divided by 5. And so once I plug this in the calculator, the reason I did this, I could have just put 4 divided by 5 in here, and I also did that, and I already told you that I still got the wrong answer. I'm getting a different answer than 0. So I wondered where was it wrong. So I used the calculator. I got 36.9, and that's the angle for B. I mean alpha. And after that's the same thing which I got here. So I applied it right and getting the same answer obviously, and even after then, as I applied it here, I still got it wrong. As you can see, I raised what I did here, but I got the same wrong old answer. So the mistake I've done is I rounded out the answer fully. So the problem is you have to apply what your calculator gets, and you should round once you get your final answer, then you round it. But when you're doing in the steps of the calculation, when you're in doing in the initial steps of the calculation, and the middle you want to not round the answer, you want to use up whatever value you get and you want to go with it. Once you do that, you get 0. So one thing you could do is, one thing which can be done is just calculate one at a time. So if you pluck one at a time, 8 costs 53.1, not adding this in the calculator, just leave this, you get a value of 4.8. And once you do this as well alone, you get 4.8, and thereby you get 0. Or if you apply this and plug this all together, you get wrong. And one of the reason is that you get a series of point values which may be different from the value which we get once we sign inverse, and this is rounded and this is rounded, thereby getting this value. But if you don't round it and you keep it as the same, I reckon that you might be able to get the answer. So I would recommend is try to do it individually and then add it, sum it all together, and thereby getting your answer. I got 3, and that's the answer. Forgot to mention, the question also asked us to put the direction of the force. The direction of the force is acting leftwards. In the vertical direction, force is equal to 0, thereby there is no direction. So in the second question, it asks us to find the two values of t at which p is at instantaneous rest. T is moving in a straight line starting from O. T seconds after leaving O, P's velocity is equal to 4t square minus 8t plus 3. So this is after leaving O. The question asks us to find the both possible t's that you could get in the question. Evidently, the question asks us to use quadratic equation, thus we use middle term factoring. So to do this, I took 4 times 3 to get 12. The reason I multiplied 4 times 3 is because the coefficient here is not equal to 1. So if you get a coefficient greater than 1 here, you must multiply the coefficient here with this term here. This term is c, and thereby you multiply it to get 12. So my product is 12 and my sum is minus 8, and I should find what sums up to 8 and gets the product to 12. I spent a minute trying to figure out which was the sum and the product that would get it, but after a minute or two, I was able to get the answer. It was 6 and 2, specifically minus 6 and minus 2, which gets us to 8 minus 8 and gets us a product of 12. Now I factorize and I get this. After factorization, I eventually got my answer 2, 3 divided by 2, and 2 equal to 1 divided by 2. So this one and this one. So overall, the first question of 2 is solved. The second one with the double I figured out I must integrate it. Took me 30 seconds to figure that out, but to integrate, I'll do that in later. This was just a review of my session in class, and it took me about 2 days to edit, yesterday being the class and today being the time 12 o'clock. So 2 days Sunday, and now today's Monday, and now I finished at 12 o'clock. I have class at 9 o'clock. Editing the video did hamper my studies, although it's my first video, but hopefully it won't be my last. So see you guys, and peace. This is the picture of what I've did overall. Whatever I talked about in the video is all in the snow.